Welcome to the class of statistics. Today we are going to learn about interpolation and extrapolation. This chapter is going to teach us about the technique of estimating the unknown value of the dependent variable for any given value of the independent variable. Interpolation. What is interpolation? It is a technique of estimating the value of the dependent variable. Now look at the example. In this example, we can see that it is a time series data wherein year is an independent variable represented as X and sales is a dependent variable on year which is denoted by Y. So interpolation will teach us the technique of estimating an unknown value of the dependent variable for any intermediate. Intermediate is in between the value. So between the first and the last value, any of the missing value can be found with the help of interpolation. So interpolation is a technique of estimating the unknown value of the dependent variable for any intermediate value, that is within the series any value is missing, so that can be found by interpolation. Now coming for the next case is extrapolation. Extrapolation is a technique of estimating the value of the same dependent variable, but the value should be in the extreme, that is outside the series. And when I say outside the series, it can be either in the last value or it can even be also in the beginning of the series. Either the first value or the last value is missing, then this can be found by using extrapolation. So interpolation is a technique of estimating the dependent value for any value of the X within the series, whereas extrapolation is outside the series. Certain assumptions that we make while calculating interpolation and extrapolation are, we can see that there is no sudden jumps in the values of the dependent variable, and it also follows certain uniformity in the values. You can see that even though the values are not increasing proportionately, but it is following a tendency. We can see that the value is increasing. It is an increasing trend and there is not much fluctuations or variations or sudden jumps are not seen in the values. So these are the first two assumptions. And the third assumption is no two consecutive values should be missing. That is, two values one after the other should not be missing. One of the values should be an interpolation value and the other value should be an extrapolation value. That is, one value within the series and the other value outside the series can be missing. So the first point is there is no sudden jumps in the values of the dependent variable from one period to another. Second point, there is sort of uniformity in the rise or in the fall of the values of the dependent variable. And the third point is there will be no consecutive missing values in the series. Next, we are going to study about the methods of interpolation and extrapolation. In this particular chapter, we will be studying two methods of interpolation and extrapolation. The first method is binomial expansion method and the second method is Newton's advancing difference method. Now this binomial expansion method is already a familiar method because we have learned this in our first PUC. Now the binomial expansion, what you are going to study now is an extension of the method what you have already studied. In your first year, you were seeing that one of the value was missing, either interpolated or extrapolation value. Whereas now we are going to estimate one interpolation and the other extrapolation simultaneously. So binomial expansion method, which is based on binomial theorem, has to satisfy certain conditions. The first condition is the values of the independent variable should have a common difference. So when we go back at our examples, we can see that there is a uniformity even in the independent variable. We can see that the values are differing by 2. It is the width between the values of the independent variable is 1. So this is known as should have a common difference. The values of the independent variable should have a common difference. The next, the value of x for which the value of y is to be interpolated must be one of the values of x. So when we get back to our interpolation, we can see that the missing value, the x value should be one of the value within the series. So studying about the conditions of binomial expansion method, we will head towards the Pascal triangle. Now this Pascal triangle is going to give us the coefficient values of the binomial expansion. I told you that binomial expansion method is based on the binomial expansion formula. Now we need the combination values NC0, NC1, NC2, NC3. Now these values are obtained by Pascal triangle. So if you look at this triangle, we can see how the values are arranged, and this is going to give us the values. Suppose the value of n is 3. In that case, 1 is the value of 3C0, 3C1, 3C2 and 3C3. Similarly, if the value of your n is 5, then these are the values of the series, wherein it's going to represent this is 5C0, 5C1, 5C2, 5C3, 5C4 and this is 5C5. So this is how we get the coefficient values of binomial expansion method. We will learn the application part of this when we start the problem. Yes, so this is the first problem that we're going to learn in binomial expansion method. Now in the given data, we can see that your age represents the independent variable which can be denoted by x, and the number of persons is dependent variable which is indicated by y. And you can also see that one of the value within the series is missing and one of the value outside the series is missing. Now how to proceed with this? The very first step is we are going to ignore the extrapolation case. Yes, here in case 1 we consider only the values till 39 and consider this problem as an interpolation problem and going to find the value for 24. So how to proceed this? Ignoring the last value here, let us start naming the values of the y variable. Since the number of persons is represented by y, the values are named as y0, y1, y2, y3, y4 and y5. We can see that the last value what we have got is y5, wherein it shows that the value of n is 5. So here in this particular case, the value of n is 5. So solution, case 1. So case 1 I have told you that it is an interpolation method by ignoring the last factor, the last value. So by binomial expansion method, we already have a formula of binomial expansion which is given by y minus 1 to the power of n is equal to 0. And we saw that the value of n was 5. So just substitute n is equal to 5. The equation reduces to y minus 1 to the power of 5 equal to 0. Next, we have to expand the binomial equation. As such, the equation is expanded as nc0y1 minus nc1y1 plus nc2y2 minus nc3y3 and so on. But since I already have Pascal triangle and all my combination values are ready, I can write the values directly. So this equation can be very simply written as just write the values of y1, y2, y3, y4, y5. Signs are always alternative, plus minus, and then these values of 1, 5, 10, 10, 5 and 1 are carried from our Pascal triangle where n is equal to 5. Now if we want to be much clear about this, we can head back to the Pascal triangle and we can see that for n is equal to 5, the values were 1, 5, 10, 10, 5, 1. The same thing is carried over here. We can see that it is 1, 5, 10, 10, 5, 1 with the respective variables and alternative signs. So the next step is substitution. We have to substitute the value for the variables y0, y1, y2, y4 and y5 and retain y3 as it is because y3 is the value that has to be interpolated. The next step is simplification. Simplify all the values by just retaining minus 10 by 3 and the answer we got is 306. Then let us get this minus 10y3 to RHS here. So this reduces to 10y3 equal to 306. So y3 is equal to 306 divided by 10. So when 306 is divided by 10, the obtained answer is 30.6. So now what is this 30.6? This 30.6 is the interpolated value of the binomial expansion. So this missing value which was not to be found has been already estimated with the value of 30.6. So with the first case, we have arrived with the answer wherein the missing value here is denoted by 30.6. So now this case is a clear case of extrapolation because all the values within the series is filled and only one of the value outside the series is missing. Now case 2 is an extrapolation, but we have a new technique of solving this problem, that is by reconsidering the same equation and then getting the answer for y6. So now this is y5, so the next variable will be y6. So instead of again starting from the beginning, we are going to remodify the equation what we have already got. So now this is the equation what we have used for the calculation of y3. Now reconsider this equation, modify it, and we are going to arrive at the answer for y6. Consider this equation for case 2. So written the same equation here, 1 y0 minus 5 y1 plus 10 y2 minus 10 y3 plus 5 y4 minus 1 y5 equal to 0. The same equation what we have used in order to get 10 y3. So next step is increase the value of the subscript by 1. So all the values of the subscript are increased by 1. So now this 0 is going to become 1. Now 1 is going to become 2. 2 will be increased to 3. And now 3 is raised to 4. And 4 increases to 5. And 5 has been increased to 6. Now this equation is the new equation that has been modified in order to get the value of y6. So what next? It's just a substitution. I know the value of y1, y2, y3, y4 and y5. So just substitute all the values from y1 to y5 and just retain y6. After simplification, I can see that these values have been reduced to 43 and along with minus y6 equal to 0. In getting y6 to the RHS, the answer is y6 is 43. So in this given problem, we could see that a case where both one value within the series was missing and another value outside the series was missing. So here we have interpolated the missing value within the series by ignoring the last factor. And then taking it as an interpolation case, we have solved the first case and then consider the missing value what we have got here. We got the answer as 30.6. So considering this answer, we have taken this equation as an extrapolation problem, modified the already obtained equation by increasing the value of the subscript by 1 and found the value for y6. So the value of y6 which we got here was 43. So the missing value here is 43. And here in this case, it is 30.6. Now this is binomial expansion method wherein you have obtained one of the value of the intermediate value and one of the missing value of outside the series estimating together. So this is binomial expansion method. Now similarly, if you go for the another problem, in this series you can clearly see that one of the value within the series is missing and one of the value outside the series is missing. So how to proceed with this? Similarly, what we did for the previous problem, we are going to ignore the last value. Consider this value as an interpolation value. Name the variables as y0, y1, y2, y3, y4. You can see that the last value is y4, hence the value of n is 4. Now just write the binomial equation as y minus 1 to the power of n equal to 0, where n takes the value as 4. Expand the equation. We already have a Pascal triangle, and with the Pascal triangle, the values we obtain is 1, 4, 6, 4, 1. So just write the alternative signs, write the binomial expansion, and get the value for y2. Once the y2 value is obtained, then reconsider the same equation, increase the value of the subscript by 1 and get the value for y5. So this is binomial method of expansion.